Today we are going to see the topic on Prim's algorithm. First is definition. Prim's algorithm is a greedy algorithm that finds a minimum spanning tree for a weighted undirected graph. Prim's algorithm is nothing but it is used to find out the shortest distance by visiting every nodes. So next we move on to the problem. This is the given problem. So we need to find out the solution. For that we need a tree vertices, remaining vertices diagram. Tree vertices is nothing but the vertices which we consider. Here initially we consider A as an initial node. So we need to visit all the nodes except A. So the distance from A to B is 3. That is the distance from A to B is 3, and there is no direct connection from A to C, and also there is no direct connection from A to D. So if there is no direct connection, we need to mark it as infinity. And then the distance from A to E is 6. That is the distance from A to E is 6. And then the distance from A to F is 5. That is the distance from A to F is 5. So we need to find out the shortest path. Here the shortest path is the distance from A to B is 3. So we need to draw a diagram between two nodes. That is the distance from A to B is 3. So we consider the shortest distance and we move on to the next step. First initially we have visited the node A and now we are going to visit the node B. If already visited, we can skip that node. So we need to visit the remaining nodes. So that is C, D, E and F. The distance from B to C is 1. That is the distance from B to C is 1. There is no direct connection from B to D. So we mark it as infinity. And also there is no direct connection from B to E. So we move on to the previous step. Here the distance from A to E is 6. So if there is a shortest distance from the previous step, we can consider it for the next step. So the distance from A to E is 6, and then the distance from B to F is 4. That is the distance from B to F is 4. Here also we need to find out the shortest distance. The shortest distance is B to C is 1. So we can connect it as B to C is 1. So we move on to the next step. That is B to C is 1. Here already we have visited that is node A, B. And then we are going to see the node C. Here the distance from C to D is 6. The distance from C to D is 6. And there is no direct connection from C to E. But in the previous node we have the distance. That is the distance from A to E is 6. So we have considered the same distance. And then the distance from C to F is 4. Here we have marked it, note down that the distance from C to F is 4. We need to find out the shortest distance. The shortest distance is C to F is 4. So we mark it, that is A to B is 3, B to C is 1, and then C to F is 4. So we need to visit the distance from C to F is 4. So we have noted it as next step. So the unvisited nodes are D and E. Already we have visited the node A, B and C. So the distance from F to D is 5. That is the distance from F to D is 5. And then the distance from F to E is 2. Here we mark it as the distance from F to E is 2. Here we need to find out the shortest distance. The shortest distance is F to E is 2. So again we need to add the distance. That is the distance from F to E is 2.